Today, we take things like GPS for granted, right? We know the Earth size almost perfectly.
Down to the meter, yeah.
But imagine going back, way back to the 9th-century.
No satellites, no computers.
And trying to measure the entire planet with, what, sticks? Basic math.
It sounds almost impossible. But that's exactly what we're diving into today.
This incredible story from 9th-century Baghdad.
It really is one of the most stunning and honestly overlooked achievements of early Islamic science, measuring the Earth's circumference.
So this deep dive is about uncovering that. How did they do it? And I guess the big question first, how close did they actually get?
That's the truly mind-blowing part. Their final calculation was 40,248 kilometers.
Okay, and the real number?
The actual measurement we use today is about 40,075 kilometers.
Wait, so they were less than 0.5% off?
Less than 0.5% error, yes. Using, as you said, essentially sticks, shadows, and careful measurement over land.
That's staggering. Nearly GPS accuracy, 1,000 years early. Okay, we definitely need to unpack how they managed that. Where do we even begin?
We have to start in Baghdad, 9th-century Baghdad.
The heart of the Abbasid Caliphate.
Exactly. This was the absolute intellectual peak. You could say it was the place where science lived. Knowledge wasn't just stored there, it was actively pursued, funded.
And a huge part of that was the Caliph himself, wasn't it? Al-Mamun?
Absolutely. Son of the famous Harun al-Rashid. But al-Mamun was different. Reports suggest he was genuinely more captivated by books and scientific discovery than by, say, military campaigns.
A patron of science, in the truest sense.
A massive patron. He founded the legendary Beit al-Hikmah, the House of Wisdom.
Which everyone knows is this huge translation center. Greek texts, Persian, Indian, all flowing into Arabic.
Right. But that's only half the story. Al-Mamun wasn't just interested in collecting old knowledge. He demanded something more.
What was that?
Verification. He paid scholars not just to translate, but to test the knowledge, to check it, to build upon it.
So don't just tell me what Ptolemy wrote. Go out and see if it's actually right.
Precisely. This culture of empirical validation was key. Why rely on an ancient Greek estimate for the Earth's size, however clever, when you have the resources to measure it yourself right now?
And that earlier estimate came from Eratosthenes.
Yes, back in the 3rd century BCE, a brilliant Greek mathematician.
His method was quite elegant, using shadows in 2 different cities in Egypt.
Incredibly clever for its time, absolutely. It provided the foundational geometric idea.
It inherently had limitations, didn't it? Measuring distances accurately back then, variations in terrain.
Exactly. There was definitely room for error. So al-Mamun's scholars took Eratosthenes' concept, but insisted on a completely fresh, rigorous set of measurements.
Combining that Greek geometry with, as the sources say, Arab precision.
And backed by the state. This wasn't some small academic exercise. It was a major funded expedition.
Okay, so let's get into the nuts and bolts. How did they physically do this measurement? The method itself sounds almost deceptively simple.
It is, in principle. First, they needed the right location. A large, flat plain. As flat as possible to minimize elevation changes.
Like a desert plain.
Probably something like the plains of Sinjar in modern-day Iraq or Syria. Then they used a gnomon.
Which is basically a vertical stick or rod.
Exactly. Planted firmly in the ground, they used it to precisely measure the angle of the sun's shadow at exact local noon. That gives you a baseline latitude measurement.
Okay, got the starting point. Then what?
Then came the really hard part, the field work. They had teams travel due north from that point.
Just walking
and measuring. They kept traveling north, constantly checking the sun's angle at noon each day, until that angle has shifted by exactly 1 degree.
Wow. Okay, stopping there for a second. Figuring out that exact 1-degree shift without modern instruments, that must have required incredible observational skill.
Immense skill and patience, yes. Repeated observations, calculations, it was painstaking.
And once they hit that 1-degree mark, what did they do?
They measured the distance they had covered to achieve that 1-degree shift.
And how far was that?
They found it to be approximately 111.8 kilometers for that single degree of latitude.
Hold on. Measuring 111 kilometers accurately. How? Were they counting steps? Using ropes? That seems like the place where massive errors could creep in.
That's a crucial point, and it's where the state's support and standardization become really clear. They weren't just piecing it out casually.
No.
They used standardized measuring ropes or rods, likely based on the official royal cubit, the dira, and importantly, Caliph al-Mamun had apparently already commissioned work to standardize that unit's length very precisely across the empire.
Ah, so it wasn't just any rope. It was a calibrated, standardized rope used by trained surveyors.
Exactly. Teams of trained surveyors whose entire job was meticulous measurement. They would have used techniques to ensure the ropes were held taut, laid straight, accounting for terrain as best as possible. This wasn't guesswork, it was systematic surveying.
So the real innovation wasn't just the geometry, which was ancient Greek, but the sheer logistical effort and the insistence on standardized empirical data collection.
That's a great way to put it. The cultural demand for verified, measured knowledge drove the whole thing.
Okay, so they have the distance for 1 degree, 111.8 kilometers. What's the last step?
The final step is beautiful, simple geometry. If 1 degree is 111.8 kilometers and a full circle is 360 degrees,
You just multiply 111.8 by 360.
and that gives you the Earth's total circumference. Their result, after averaging, was that 40,248 kilometer figure.
Incredible. And you mentioned averaging. They didn't just do this once.
No, that's another layer of their rigor. They actually sent out 2 teams from the starting point.
Oh, really?
Yes, one team traveled north and another team traveled south, performing the same measurement, finding the distance for a 1 degree change.
Why do both?
To double-check the results and average them out. It helps minimize any potential errors caused by localized terrain variations or slight measurement inconsistencies. If the northward and southward measurements roughly agreed, it gave them much higher confidence.
That's proper scientific method right there. Controls, repetition.
Absolutely. It shows a deep commitment to accuracy, even with what we'd consider primitive tools. Wooden rods, ropes, careful observation. But the logic was sound.
It really highlights what systematic thinking can achieve.
Which brings us to this so what? Why does this specific achievement matter so much in the bigger picture?
Right. Because you often hear this narrative that Islamic science was mainly about preserving Greek knowledge during Europe's so-called Dark Ages.
Exactly. And while preservation and translation were vital, this measurement shows something more profound was happening.
They weren't just reading Eratosthenes, they were testing him, refining his work, arguably correcting him with new data.
This was contribution. Active, original scientific investigation and improvement. It completely shifts the perspective from a passive library to an active laboratory.
And did this work have a lasting impact? Did later scientists know about it?
Oh, absolutely. It had a significant influence. Their methodology and results became foundational for later Islamic geographers and astronomers.
Anyone in particular?
The great scholar al-Biruni in the 11th century is a prime example. He was a polymath, physics, astronomy, history, you name it.
And he knew about the Baghdad measurement.
Yes, he studied it. But what's fascinating is that he wasn't content to just accept it. Inspired by their quest for precision, he developed his own, completely different method to calculate the Earth's size.
A different method. How did his work?
It was arguably even more mathematically sophisticated. Instead of traveling long distances, he used trigonometry and the height of a mountain overlooking a flat plain or the sea.
Wow. So from a single point.
Essentially, yes. By measuring the angle of the dip of the horizon from the mountaintop and knowing the mountain's height, he could calculate the Earth's radius, and thus its circumference.
And how did his results compare?
His results closely confirmed the earlier evasive measurement done by walking, which, in a way, validated both methods, the painstaking field work and his ingenious trigonometry.
That's a fantastic example of scientific progress building on itself.
And this chain of knowledge, Eratosthenes, then the Baghdad refinement, then al-Biruni's further work eventually made its way west, didn't it?
Yes, slowly. Through translations into Latin, often centuries later, these Arabic texts carrying this improved data and methodology did eventually reach European scholars.
But it seems the specific contribution of the 9th century Baghdad teams often gets, well, sort of glossed over.
It does. Textbooks sometimes jump from the Greeks straight to the European Renaissance or Age of Exploration, minimizing this crucial intermediary period of active scientific advancement in the Islamic world. It becomes a bit of a buried legacy.
Which is a shame, because this knowledge wasn't just theoretical. It had immense practical value for their society.
How so?
Well, think about it. Knowing the Earth's size accurately, understanding latitude, this was crucial for cartography, for making better maps for trade and travel across their vast empire.
Makes sense.
It helped with agriculture, understanding seasonal changes linked to the sun's position, and perhaps most importantly, for religious practice.
How did it connect to religion?
Determining the Qibla, the precise direction of Mecca for prayer. For Muslim communities spread across continents, from Spain to China, calculating that direction accurately required sophisticated geography and astronomy, which relies on knowing the Earth's shape and size.
So this knowledge was woven into the fabric of daily life, administration, and faith. It wasn't just an academic curiosity.
Not at all. It was practical, spiritual, and also, frankly, a matter of intellectual pride and demonstrating the capabilities of their civilization.
So, stepping back, the key takeaway isn't just the number, 40,248 kilometers, it's the mindset behind it.
Exactly. A mindset that demanded evidence, that rigorously tested existing knowledge, that wasn't afraid of foreign ideas, but instead sought to translate them, examine them, verify them.
And ultimately make them better.
It's a powerful example of the scientific spirit in action, achieving remarkable things with determination and logical thinking.
And that leaves us with a really interesting final thought for you, the listener, something that comes directly from digging into how we even know about this measurement.
Yeah, this is quite striking. For a project this massive, this important state-sponsored, likely costing a fortune, taking years you'd expect a big official final report, right?
Some grand document presented to the Caliph.
But as far as we know, no single comprehensive official report from the expedition itself survives.
So how do we know the details, the method, the result?
We know about it mainly because later scholars, astronomers, and geographers writing in subsequent decades and centuries referred to it. They mentioned the experiment, cited the results, discussed the methods when doing their own work. People like the historian E.S. Kennedy had to painstakingly piece the story together from these scattered references in various manuscripts.
Wow, so the evidence is fragmented, referenced indirectly in other works.
Which really makes you wonder, doesn't it?
Yeah.
If an achievement this significant is known mostly through these secondary fragments, what other major scientific or intellectual breakthroughs accomplished purely through human ingenuity and critical thought might still be buried, documented only in passing mentions, in footnotes, in the margins of texts we haven't fully pieced together yet?
What else might be waiting to be rediscovered?
Exactly.